This is working this time. Here we go. What's up? We got Carnage, that what kid, and Ramton. What's up? What's up? My Noise is like, yo, is this gonna start 2 minutes late? I was like, no, I fixed my clock, and then I spoke too early because
That's dope.
I went to hit start streaming on OBS and I got like some NVENC error, and I was like, oh fuck, man. So
How's it going?
I guess I did start 1 minute late. What's up, Ramton, dude? How's your wonderful Wednesday going, dude?
Not bad.
Bad? That's good. That's cool.
Yeah, that's good.
We got a lot of new students in the Discord. Let me see. We got that one kid and Carnage, or Carnage with a Z. I haven't. That's how do you pronounce it? Is that with like the Z like an A? What's up? First office hours. Yeah. What's up, dude? What is? Yes, sir. And we got Ishi in here and Teacup. What's up, Teacup? Hey, Teacup, come up to the stage, Teacup. Come up. I got news for you, dude. Got news.
Alright, that's low.
What's up, dude? Teacup, like, did you know what I did today? Did you know what I did? Did you know what I did today? I did talk to your mom. There we go. Nice. But not in that way. No, I talked to your mom because your mom was curious about what this whole thing is. She's like, I know my son has been going to it a lot. He says like, Mom, I have to go to class. I'm like, oh, that's super cool. But yeah, she agreed, she approved, and then, yeah, as soon as I checked to make sure she's got the address and whatnot put in, we're gonna get you your gaming desk. See? Things do happen, man. W, dude. Yeah,
That's
nice.
dope.
You brought up a good point, which I didn't realize to talk about, but I'm fine with it either way.
Yeah.
I should have said a gaming standing desk, but just a regular desk is
Oh
fine,
my
but
god,
just-
dude. Yeah, no, dude. There's gotta be at
I'm
least,
not gonna.
gotta be around $100. I can't be buying you $400 gaming desks.
Ah,
You know,
bro,
like,
I need a
because
standing
I need the
desk.
standing
obviously.
gaming. For those that are new to the Discord, so here I'll show you guys on the stream. Where is it? Okay, Discord. There we go. Yeah. So we have a bunch of prizes and whatnot that you can win, and they are real. Like, so my first problem, or my first my first hurdle I have to always deal with when I start getting new students here is the students don't believe this is real. They believe it's like
I
it's a
don't
scam.
believe you, Lord.
Yeah, they don't. So that's why I have this prizes proof channel where I can literally show you like the hundreds of gift cards I've bought for students. That's real. I've even mailed Oculuses to people. Some people have gotten PlayStation 4s. Like, it's real. Like, here's when I gave out a PlayStation 4 and an Xbox. My beard was a lot thinner back then.
PS5.
What's up? Sorry,
That's a
PS5.
PS5.
Sorry, PS5.
Yeah,
You're
damn.
right, bro. And this was also during COVID when it was like impossible to find these things. Like, these things were retailing for like 1,000, and I managed to score one for pretty close to retail. Or sorry, they were reselling for 1,000. Anyways, so once the students believe this is,
Hook me up.
what's up, Rampton?
Like, you gotta hook me up.
I know, right? Yeah. That and then what was this? This was the laptop that Nick won. Nick's won a lot of the grand prizes somehow.
I'm
I
mad
don't
about
know.
that.
I know, right? You were so close. But anyways, so yeah, these are real prizes you can win and whatnot. Once I convince the students that that's real, the next step, which is always kind of the harder one, is convincing the parents that this is real. Which I understand. Like, don't trust anything on the internet, honestly, except me. But yeah, once you get through more bond coins in the server and you get to higher tiers, you can get to even cooler prizes, such as those found in the vault. So these are like, for instance, we're giving away an Xbox wireless controller, 10,000 Robux, a gaming desk, doesn't have to be gold. Some of these have already been claimed though. Someone already claimed the 13,000 V-Bucks. Someone claimed the Nitro for a year. We still got a headset and whatnot. You're about to claim the desk. Yeah. But these gifts I have to mail to people. And I don't want you giving me your address. I want your parents giving me your address. Because you should never give your address out to strangers on the internet. Even though, like, I'm not a stranger, but, like, you know, just as a general advice. Anyways, so, yeah. So, I have to talk with the parents once I get once you get to a prize level that I have to ship you something. I have to talk to your parents, and that's always fun and interesting. But it was really nice talking to your mom. She was She was super appreciative of everything. She said what we're doing is great and like awesome. And I'm like, oh, I feel good. You know, that like warmed my day up. I was like, yeah, cool. Always love it. All right.
Oh yeah. Anyways.
yeah.
I just realized the desk technically can be a standing desk because it has the little elevated thing on it.
Ah, okay. Yeah, I just the ones that are like mechanical and whatnot become a little
Yeah,
harder.
no,
I guess
that's kind of expensive.
those get expensive. But if if you can find one that's a standing desk around $100, I'll get it for you. It's cool. You know, I think you probably you know the dimensions of your house the best, so you find out what works for you. You know, we'll do it.
Guys, he said it was a go. I'm gonna find the play. I'm about to find the rarest thing that I'm gonna flip. It's gonna be $100.
Oh no, no. I want you guys to get the. So this is also, and I wrote this in the letter to that. See how this helped also for me. I took like a couple hours writing like a pretty big letter detailing what we do here, what Teacup has done, all his accomplishments, and then I attached my IRS forms, my driver's license, and like my state of California incorporation documents. Because I was like, this. Like, I hope this is. And even your mom says, she's like, you didn't have to do all that. I'm like, I feel like I did because you said no last time I tried to mail something. So like, it's okay.
She actually didn't have a saying that. That was just my dad saying that.
See that, and I think that. So this is also a good strategy, guys. If dad says no, go to mom. Or if mom says no, go to dad. Somebody will say yes.
Go to the cooler parent.
Yeah, play them against each other. I know parents love that. Be like, but mom said yes.
Mom said yes, so I said no.
Yeah, then it becomes start pitting them against each other. But yeah, so it helped. It helped Teacup. See, it helped for you to print something out and give it to them because if I send them an email or something, they're just gonna ignore it. If the parents see,
read it.
I hope they did because I wrote a lot of nice shit about you.
I think they read it because they put it in like I kind of didn't. I just kind of like I put it behind them while they were playing a game, and I said,
"Oh, that's too funny." Here, I have something for you, and then they looked at it. They're probably like, "What the fuck is this?"
I had it in some confidential files.
Oh wow, that's cool.
I grabbed the confidential, stamp went bunk.
Well, see, and it worked. See, it worked because now I have your address. Which means now you can win physical prizes. I can ship them to you, and you have the role now that says does not need an adult. Because once I get parent permission to like ship stuff to you, like you're good. Cool. That's all I need. Just need to talk to an adult at some point.
It's not actually my address. It's like their work address.
That's fine. I don't care whose address, as long as it's an address. Like Nick has done this. I've mailed things to Nick's like grandma or something because like she lives in. I don't know. She lives somewhere in some type of home where like they have like a front office and stuff, and so they're more likely to get packages. That's another thing. Like please, if you give me an address, make sure it's an address that shit doesn't get stolen from. I can't afford to reship things. Like that's a lot. Anyways, all right, cool. Let's start off the stream. We got a lot of nice questions here.
Can't wait to start about my progress in my northern test.
That's good. Welcome everyone to Office Hours, Savage Education, Dr. Gold, and joined with Ramtin. We're here to answer your math homework, science homework, all types of fun stuff. Yes. What was the first question we had? Who asked one? I think Noise asked one.
Noise has gotten a killer question.
Jesus Christ. What is this, bro?
Where?
He put it in the help screenshots.
Yeah.
No, he didn't. Oh no, I did.
Yeah, he did here.
Dang,
wow.
Question skipped.
Well, no, I will get to that one. Let me hear. What is the true nature of dark matter? That's a good one. I like that. That's a cool conceptual one. That's a good one. That's almost like a good golden hour topic.
I might have to skip on this. Unless Noise got the answer, I can explain. Because the thing is, like, with the finite measure, I'm rusty. Because this is pretty much using so many
concepts. Someone program it?
Someone program it. Oh, no, dude. Shit breaks me,
I don't even know where he's getting measure theory questions. Because, like, this is like a 4th year level question.
Yeah, dude, Noise. Where is this coming from? Are you just trying to learn really cool stuff? I mean, I'm down with it.
Like the science Olympiad.
Yeah.
I can explain how each part needs to be done, but the
Let's
the
ask him.
biggest thing is knowing what the
He
advanced
says
analysis.
it says
Yeah.
advanced analysis. I'm like, oh wow.
Yeah, like I haven't looked at advanced analysis. I know just kind of like elementary analysis. I haven't studied measure theory that much.
It's,
So
it's
if you have the answer,
we can
I will
explain
be
the
able
answer too.
I can explain the answer because so the Lipschitz conditions is like, I mean, they already gave it to you, and let me actually hop on the
Yeah, you can hop on it. Yeah, go for it.
screen as well.
And then we'll talk about dark matter. And Bob's got a good question here too. I like Bob's question.
So the Lipschitz condition is just this line that they've already given you. So, but plus some more, because I think what
he says he found it in the mathematics Discord server. I know which Discord you're talking about, like the massive mathematics Discord.
Wait, is that the
Official Discord.
mathematics?
Yeah, there's I know because I think I'm a part of it
Is that
because
the one
I
with the Mandelbrot set as the
where is it? It was this is it. This is the
yeah,
official.
I'm in that as well.
Well, it's massive. Yeah, I think this is like the biggest
Yeah.
mathematics Discord they have.
Is that
We'll
the
see a
one that?
partnership there.
Oh, actually, wait. If he is, one sec. Let me check something.
They probably have the answer if it's in that big Discord.
Yeah, let me.
He's hunting down the answer.
Here, let me do let me answer Teacup's question in the meantime real quick. All right, Teacup, you were asking about what is the true nature of dark matter. That's actually kind of cool. So, do you know why dark matter is called dark matter?
No, I don't.
Okay. What do it mean for something to be like dark? Like, what happens when you go down like a dark alleyway? Like what's up?
Lumens stop existing.
Good. Yeah, you can't really see shit, right? Dark matter is like basically like matter that we cannot see. Okay. And it's actually interesting to talk about like, you know, whether we can see something because even that has kind of some layers to it.
Can I see you on this computer?
Oh,
Yeah.
Actually,
What's up, Ramsey?
Yeah. Sorry. Keep going on that. I'll say something. Else.
Okay. Cool. All right. So yeah. So just in terms of seeing something, that actually depends on like what the thing is that is doing the looking, right? So for instance, dogs see different things than we do. Insects see different things than we do. Bats see different things than we do. Actually, bats are blind, right? Bats don't see shit at all, I think. I don't know. Let me see. It's like, what is it? Wavelength. This is what I want. I want like a little graph of this. All right, here we go. Yes. Let me copy this image in real quick. Okay, so light is a wave and has what we call a property to it, which is called the wavelength. The wavelength is basically like how big or small the wave is. And within the universe, there's a ton of different types of waves, okay? There's, for instance, gamma rays, there's X-rays. You've heard of microwaves, right, before? That's what you do to, like, make nachos, right? AM radio, FM radio, right? AM, FM. You got long radio waves. You have all these different types of waves. And within there are also what are called light waves, which we call, like, the visible spectrum. And those are waves that have wavelengths from 380 nanometers to 750 nanometers, okay? As humans, these are the wavelengths of waves that we can see. Now, if you've ever looked at something like, you know, like night vision goggles or whatnot, have you ever heard of those night vision goggles, right?
I have some.
Do you have some night vision goggles? That's pretty dope.
Well, it's actually night vision binoculars.
Yeah, well, you guys have seen these before. It's the, was it, night vision goggles. They use them in like all the time in the military and stuff, like this type of stuff. Oh wow, we can buy them on AliExpress for $37,000. That's pretty cool. Anybody want to buy me? It says $36,000, dude. Zero sales. 3% off though. I'm down with this 3% off. Free shipping too.
Go, that's what you're buying me now.
Dude, look at this guy just like, what?
I'm with
$37,000.
that.
Anyways, how those work actually is very cool. They use infrared. They use the IR spectrum of light. So what these things do is they shoot out a beam of IR light and then have special detectors that can look at the reflections based on it. And so then they translate that into something visible that you can see on a screen. That's why, they're like IR goggles, or night vision goggles. And the cool thing about IR is that IR doesn't really look bright or whatnot. So if you're in the dark and someone is beaming you with like an IR flashlight, you can't see it. But an IR detector could. And this is how like night vision goggles work. I think like certain insects and whatnot also see within the UV range. So there's all types of stuff. But anyways, this is all different techniques of waves that we can use in order to see matter. We also use things like X-rays, for instance, to see your bones, right? If you look at, if you break your arm or something, they run X-rays, and that's a way to like detect like matter that's like underneath your skin. I don't know about microwaves, but anyways, all these types of waves are different ways to detect matter. Dark matter is matter that can't be detected by any of these waves. Like it doesn't show up. No matter if you use night vision goggles or if you use an X-ray or you use, I don't know, like a gamma ray telescope or something, you cannot detect the matter using any of our conventional ways of using waves. So that's why we call them dark. And then, however, matter does have this property where all matter has mass, right? That mass, like kind of like weight and whatnot. And everything that has matter is attracted to other things with matter by what we call like the gravitational force. Okay? So, for instance, if you have like, here, let's make these different colors. Let's say we have the Earth and we have the sun, right? The sun is massive. There we go, right? Yeah. These are attracted to each other by what we call the gravitational force. This is what we call Fg. And there's an equation for this. This has to do with, it's called this big constant G, and then it's mass of the Earth, mass of the sun over r squared, where r is the distance, it's really distance from center to center, between the Earth and the sun, okay? And everything everything in our universe, if it has mass, is attracted to other things with mass. It's kind of a cool concept in science. On like day-to-day life, like, me with, my phone, I know I'm attracted to my phone because Facebook and Instagram tells me so. But also, I'm technically attracted to my phone by gravity as well. It's just that force of gravity between me and my phone is so small that I can't really detect it. Okay?
Yeah, you're not being kidnapped by your phone.
I'm not. Yeah, don't be kidnapped by your phone. I know it's trying to rob your attention span, guys. But so what happens is that when we look at things in the cosmos, up in the universe and whatnot, what we start to notice is that, for instance, there are some objects, for instance, that seem to be in orbit with something else. Like they seem to be moving in some sort of like way where it would appear that there needs to be something else with a lot of mass in the center, okay? The same as like, the sun and the moon. There's some sort of sun here that must be causing this thing to orbit around it. However, we can't detect what this is with any sort of telescope or, whatever conventional methods of looking at stuff in space. So we determined that there has to be mass there, but it's dark mass or dark matter. And we do that from physics. Like physics tells us there has to be something here because the only way something would be orbiting in this direction would be if there was another mass here, but we can't see it. And so that's in a nutshell what like dark matter is. Yeah. Stuff we can't see, but it pulls other shit into it, basically. That's my basic description of it. That make more sense to you, Teacup? Yeah, it's kind of cool.
Yeah, it's pretty cool.
It is pretty cool. Yeah. Oh, you're. It was I was asking your mom like what you want to do in life or whatnot, and she said like Disney Imagineer or something, and I was like, oh, that's pretty cool. I'm sure that, they would probably do some cool shit with this too. Honestly, like this is all some very, very, very cool animation stuff you can do. Nice Teacup, bond coin for you. Congrats.
I'm gonna ask more questions. What would you ask?
I don't know. We were just talking. It's okay. It's cool.
Hey.
He's like, hey. Yeah. Cool. Teacup, talk to me later this evening, I think, and then let's find out what type of desk you want and whatnot, and I'll get it to you.
I'll make sure I'll kidnap you when you're doing something.
Yeah, kidnap me when I'm doing something. All right. Let's go to Ramton. What's up with Noise's question?
Can I just ask you after you finish recess?
I have to go running, but after that, maybe. Ask me like an hour after
I'll
recess.
ping you at like 10 p.m.
There you go. Do that. Okay. What's up, Ramton?
Wait, no. It's recess 8.
Yeah, I was gonna add something to the last thing as well.
Oh yeah. Please do. Sorry.
Yeah. So, another thing, I guess, to just kind of add to this is like, I don't know if you guys know what centripetal force is.
Oh, we're getting raided.
But-
That's dope. What's up, guys? I've never gotten raided by someone else.
Yeah, I don't think this has never happened.
That's cool. Thank you, English Lessons TV. Hello, English Lessons TV. Thanks, man, dude. I appreciate the raid, dude. What's up, dude? We're learning about dark matter.
Oh, nice. Yeah.
Frenzy.
Yeah. So, when things are going in a circular motion, I guess this is a little bit simplified version of this because you can always there's a lot more going on. But if you look at something going in a circular motion, well, there is a center-seeking force that is going to point to the center, right? This is called the centripetal force. And so the formula for this is mv squared over r. Now the force that is center-seeking for this is exactly what Gold said, which is gmm over r squared.
Mm-hmm.
Right. So this small m is the mass of this object right here,
Mm-hmm.
and then the big M is the mass of this object right here.
Yeah.
So one thing is that you can see is that it actually doesn't matter
What the mass of the small object is, yeah, right?
Yeah. So
Yeah.
we can cancel this. Okay. Now for v, this is what we call the tangential velocity. So
Mhm.
it's like the speed of it in meters per second. So you can find it in terms of orbital velocity, which is v is equals to r times omega, right? Where r is just this radial distance. So it's that. And omega is what we call angular velocity. So how fast is spinning?
Mhm.
Velocity. Okay. So then if we replace this into here, we have r squared omega squared over r equals to gm over r squared. Then, okay, this r cancels out with one of these. This comes down. We get omega is gm over r cubed square root. This is actually similar to one of the questions that someone asked.
Yeah, someone did ask this earlier. Yeah.
Yeah, so if you want to make this look like exactly what they were looking for, you can do some manipulations, but I'll say that. So anyways, this is the speed that this is supposed to have. Now, this is for obviously one mass at the center.
Right.
So when they looked at the
Are you gonna get into the
galaxy-
2-body problem? You're gonna get to the 2-body problem or something?
Or
the 3-body?
I mean, no, it's just they kind of it's kind of like computational methods that they have to use otherwise. But essentially, they pretty much calculate the mass of something. You can kind of, it's like if something is going around this with even mass distribution, you can kind of just do some integrals and stuff like that. It's essentially the same concept. And then once you figure out this orbital velocity, you expect it to be a certain thing, right? But depending on the mass that exists in the universe, essentially.
Right.
So what you would do is that instead of looking at one object spinning around another object, you look at one object spinning as part of the whole Milky Way galaxy. And then if this is spinning, well, the way that you can figure out the velocity of this well, okay, we can just make observations, figure out this R.
Mhm.
Okay, that's easy. This G is just a constant. It's like 6.67 times 10 to the negative 11, if I'm not mistaken. So this M is the thing we have to figure out. It's the mass of all
At the
these
center of
stuff.
all this, the supermassive black hole.
Or well, we don't know exactly.
Right.
This is prior to everyone knowing that there is a supermassive black hole. So you add up all of these masses by, pretty much they use a luminosity, but depending on the amount of light that comes from something, and the distance, and the flux that we get.
You can estimate like the amount of like gas that's like burning, basically.
Yeah, and then you can guess the mass of the galaxy. And then when you add that up, you realize that you're
like, oops,
actually underestimating.
we're off.
Yeah.
Like we're missing some
We're
shit.
off.
Where'd it go?
Yeah. And then even if people were to be like, okay, we made some errors, let's add in some stuff, like maybe there's some stuff that we're not accounting for, you would still not get to this.
No,
So
you get
then
nowhere
people
close. I
know-
think there's a huge proportion of the universe, right, which is dark matter, right?
Yeah. So there's 4 times as much. I think mass.
4 times as much. Wow.
Normal mass is 5% of the universe. Around 21% is like something the dark matter, and then the rest is dark energy.
Dark
Right.
energy.
So yeah, something like that.
That's all. That's all the Sith Lords. That's Darth Vader.
Oh, there we go.
Yeah, that's the percentage over there.
24. Okay, yeah.
That's a lot,
And
dude. I
then-
didn't realize the dark energy is that much. Like, wow. What? So
Yeah.
actually, this is a good question, Ramton. What's the difference between dark matter and dark energy?
So dark matter, you can expect dark matter from this pretty much this orbital.
Yeah.
what's it
Creating the gravitational pull and whatnot.
called? Gravitational pull.
Sure.
You get dark energy from Einstein's field equations. So it's like this one. I forgot Einstein's field equation exactly. Einstein field equation. It's just like a whole bunch of tensor. There we go. Yeah, it's the Ricci.
Oh, this
Tensor.
thing. Yeah, I remember this. Dude, tensors scare me, dude. I get so scared about tensors. I remember when I was getting in. Yeah, there you go. You got it.
Wait, did I put it on the screen?
Yeah, you put it there. It's at the bottom.
Oh, there we go. Okay, how can I make it bigger?
Here, I'll rotate it for you. You gotta use this and or whatever. Whatever. It's kind of straight.
Yeah, so this is the equation, and where there is one term. Well, this is actually another. There's a better one. Yeah, this is the one actually. That's without the dark energy. This
Yes,
is
Strandy was saying, is there something like matter, or is it just Marvel and DC stuff? And like, no, it's real. Like, it's real shit.
Yeah.
You know.
So yeah, delete the other one. This is that one doesn't take into account dark energy.
Okay, let's get rid of that.
This one does. Yeah. So you got this equation, which describes just the motion of something like throughout universe, and you can pretty much just explain everything in the universe like using this equation.
Mhm.
So this is the term that is pretty much the expansion of the universe. This is where you would pretty much expect if there is some kind of like an energy in the universe that causes it to expand, then this will be due to this term. Now Einstein, when he did it, he actually set this to 0 because he said universe is static. But he put it
that's
in
wrong,
there.
right? The universe is
Yeah.
not static.
So he expected the universe to be static.
She's a big girl, and she's getting bigger.
Yeah. And then he was like, okay, so the universe is static, so this is 0, but mathematically it would make sense that if there was a expansion, then there would be like another contributing term. And then once you actually account for like the energy of the universe, so if you actually measure the energy of the vacuum, then you would end up getting some number that is like kind of big. And the energy of the vacuum essentially comes from that we think that if the vacuum, people think it's empty, well, there isn't. It's actually energies with what they call quantum fluctuations in just vacuum. And then That also happens because of the annihilations of particle antiparticles that are like virtual particles and all this stuff. So we can talk about that tomorrow because I feel like it would get too much into it. But
Yeah, no, that's
essentially,
cool.
it comes from this, where if you actually were to measure the expansion of the universe, you would realize that there's something adding energy to the universe, and it's a lot. And so
Yeah.
where that dark energy comes from.
Oh.
And the universe is expanding, and that expansion is accelerating. And so one thing that I will also later talk about is that this expansion is faster than the speed of light.
Oh shit.
Yeah.
Things
This
can't
is
go faster than the speed of light.
Yeah, so faster than the speed of light. So this is the thing. The Einstein's equations that says nothing can go faster than the speed of light is that things cannot move in space faster than the speed of light.
Oh, okay,
But
okay.
the space itself could expand faster than the speed of light.
Oh, that's
Right? So
interesting.
you can kind of think of it as like if you're rolling like a marble on the sheet, right? And you would say that this marble cannot go faster than like c, which is the speed of light on this sheet. But what if you started to stretch out the sheet like faster than that speed, right? So you could stretch out the sheet faster.
But then the relative speed of the marble would be less than the speed of light, right? Because then it's
Yeah,
it's covering less distance.
Yeah, so that happens due to like some relativity stuff. Like if you are in so locally, I mean, it's easy to prove that you're never going faster than the speed of light. Globally as well, because if you are in vacuum, you're considered a what's it called?
Stationary state. What do they call? Yeah, inertial reference frame. That's it. Yeah,
inertial reference frame. So you're technically not moving in space because there's nothing around you, because there's no way for you to measure motion. So that's it gets a little bit like but if you want to measure like, oh, am I moving faster than the speed of light from something? Well, you could be moving faster than the speed of light from something, because we actually do see like if you look at a really far object, you would see its light and then it would dim out and die, and then like you would just never see the light again. And like if it was like a star, you never see the star ever like explode. Like if we could have looked at the edge of the universe and there's a star there, at some point the light is coming to us, but that star will end up moving away from us faster than the speed of light. So then the light that was traveling from that star to reach our eye will never end up reaching us.
Oh, I see. It's kind of like almost like a Doppler effect, but just like
exactly. It is exactly. Yeah, it's just called the Doppler effect as well, because like that's what redshift and blue shift.
Redshift and blue shift. Yeah, we've talked about it a little bit. That's cool.
Yeah. So then, like pretty much, if something's faster than the speed of light, we only would know that if something was moving slower than the speed of light away from us, and then it like accelerated and became faster. Because if it was faster than the speed of light, like from the beginning, we wouldn't have known.
We wouldn't have ever seen it. We would have ever. Yeah, it would just escape us.
Oh, yeah. So cool. there is evidence that actually this is like happening, and you would see that. So how they measured also the acceleration of the universe expanding is actually through like supernovas, which is like kind of cool. We can talk about that at some point as well, because I don't want to get into it. Because this is
we can go down the rabbit hole forever of all this. This is all cosmology shit.
I have a kind of unrelated question.
Okay, what's up? Ask a question, and then here I'm gonna get Bob. Bob, come up to the stage. We'll do your question next. What's up, Tico?
Quite unrelated. Would it be possible for a jet to reach like close to the speed of light, or like Mach 10 or something? I don't know. That's not close.
Well, it'd have to be like Mach 10,000 or something.
Is it possible?
So there is a way you can actually calculate the amount of energy. So I think this goes back again to special relativity.
Right. You start gaining mass, right? Eventually, like if you start going so close to the speed of light, like you start, I think, gaining mass. That's what happens, right?
Exactly. So because your mass is going up, your acceleration is gonna go down because your engine. Let's say your engine is creating some amount of force that is propelling you forward. If your mass is going up, then your acceleration has to go down.
Yeah.
So like in
So
order for
eventually it
you
would
to
drop out of the
accelerate,
sky.
sorry.
You would say,
So
Bob?
would it eventually just drop out of the sky?
Yeah, it would be super heavy. Is what it. There's a whole that's the whole Einstein equations, right? P squared m squared or whatever is plus e m what mc squared has to equal 1 or something.
It's pretty much the square of it's m squared c squared equals to p squared c squared
Yeah.
plus
This equation's like
right.
the bane. This question is the bane of like
Yeah.
second or
squared.
third year physics classes when you have to start doing relativity. You're just like fuck.
Yeah. So this is the actual
E equals
equation
mc
that you
squared.
get.
Right. Everyone
if-
learns that this is much less than this, so you just get rid of it.
Yeah. So if the p is approximately 0, then you get e squared equals to
M squared c.
c4, which is
Right.
equals mc squared.
Right. Because
This is called the what's it called? Inertial energy. I think that's what they call it. Sorry,
rest
mass
energy. Rest mass energy.
Yeah.
That is really cool.
Stranzy says light isn't the fastest anymore. Sad childhood.
We killed off
Everything you've been taught is a lie.
Well, not really. It's just kind of like the fact that the universe expands faster than the speed of light is kind of crazy. So
It is. It's
we
a
can-
mind fuck, dude.
I can in that math channel actually I did like 2 lectures.
Oh, did you? In the big
yeah.
mathematics, the mathematics Discord.
Yeah. I ended up actually what's it called?
They have guest lectures, do they?
Yeah, so like I was like, oh, I kind of want to like do this, and they said, oh, you can like do it on our lecture, and I did one on linear algebra.
Oh, that's
I did
sick.
one on like introductory quantum mechanics.
Oh, I should talk to these people, honestly. You know, now that we're at
Yeah,
like a
like-
certain size, maybe I can like start. Because you know they always say like no spam, no promo or whatnot. You know, but I'm just like, oh, maybe I can just get in touch with one of the mods.
I checked. I like messaged 2 of the mods. That's
Okay.
how they got back to me, pretty much.
Oh, cool. Maybe share with me which mod you talk to, and I'll hit him a
Okay,
message.
If
I'm
it's
curious.
not deeply engraved into my DMs, I will.
I know, I got so many DMs in my Discord. It's nuts. People are like, "Did you check my ping, Dr. Gold?" And I'm like, "You know how many pings I get a day? I get like thousands." I'll try to get to them. All right, that's a very cool question, and you know I know some of the people in the chat are like, "Oh, this is going over my head faster than the expansion of the universe." Like, I get
the question that he says, "Is there antimatter?" Yeah, there is.
oh yeah, there's definitely antimatter. We've done it. We've made antimatter.
Yeah.
We've done it. That's like a Star Trek thing too.
Dang, I'm gonna need to follow this question up with like nuclear stuff.
There you go. Exactly. Yes.
Yeah,
Yes.
that's it.
Hans, we're here. We're here for it, dude. We're also here for like basic questions
Science,
too.
yeah.
Yes. Science, great. Math, great. What's up, Bob? Bob, what's up? How you doing?
Hello?
Hey, Bob's getting ready to go to college, going to USC. Do they have like a summer thing that you're gonna go to? Do you have like an orientation?
Yeah, I think so.
That's cool, man. Let me know when you're in LA, dude. I'd love to give you an autograph or something. I don't know. You know. Anyways, you're gonna have a blast. Okay, cool. Here we go. This is kind of almost a physics question, isn't it? Yeah, this is kind of a physics question. Okay. Is this the one you need help with? You probably need help with all of them, but you let me know which ones like you need the most help with.
I think I did this one already.
Okay, this one's fine. Okay.
And
This
then
one's
that
fine.
one-
Okay. All right.
I don't know. That one's not fine.
Oh, this one's not fine. This one's not fine.
No.
Okay. Well, let's find
She
out.
told me to plug it into a calculator, but I didn't know how to plug it in.
Oh, okay. All right. So you found out this is the equation for the velocity, and then you find the acceleration, and then they want to know when the speed of the particle is equal to 1. So they want to know when this right. And so there's, you know why she puts the absolute value here? Do you know why?
Because you go forward and go backward and then go forward and it's still the same thing.
It's the same thing. Yeah. Velocity is speed with a direction, and that direction, if you're only moving in one dimension, will be a plus or minus. So it's like left, right, up, down, or something. Okay. Yeah, this one's not too bad. Okay, so once you've got the equation right here, let's throw the calculator up. Love this TI-84 thing. Noise. Yeah, you've been executed by your math teacher? No, dude. Don't get executed by your math teacher. Noise. Let me help you with stats at some point, please. That stuff is painfully easy compared to the other questions that you ask. You should be able to do that. Like, chi-square test is not that difficult. Like, you know how to do it. All right. Anyways, okay, so we want to graph when this is equal to 1, right? So I'm
Yeah.
going to put this in my calculator here, and then you can actually put absolute value as a function. Do you see how it puts like the 2 bars in between it?
Wait, how'd you do that?
So if you go to second and go to catalog down here, you'll see something that says ABS. That means absolute
okay.
value. Okay.
Okay.
So now that I have this in here, I'm going to replace t with x, right? So this is x to the 6th minus 13x to the 4th, and then was that plus 12, right?
Yeah.
And then technically I need to put parentheses, right? Because we gotta divide something else, right? So I'm gonna do second insert and put a parentheses around here. Let's go all the way over. Okay. I'm gonna put a parentheses in here. Okay, great. All right, and then insert divide by. Okay, here we go. And then this is gonna be 10 x to the 3rd plus 3. Do we have our end parentheses? Nope, not yet. Second insert that. Okay, cool. All right, so that's our function. No, oh, fuck. I put it in the wrong place. Eek. There we go. Get rid of that one. All right, good. All right. That is our function, as messy it is. And then I want to find out where this function intersects 1, right? So my next graph is going to be y equals 1. You see that? And then you need to graph this, okay? And what I'm going to do is I'm going to use the information that they already told. Do you see how they told me here that t had to be between 0 and 2?
Yeah.
Right? That's going to give me an advantage here because before I even graph this, I'm going to go to window here. I'm going to set my x value, the x minimum. This is like the minimum value I want to graph. I'm going to graph that starting at 0, and the maximum is going to be 2. That's like already setting my domain before I even start. Okay?
Yeah.
Okay. And then I know I only care about when the graph is at y equals 1. So what should I set my y minimum and my y maximum to? An idea.
1.
Yeah, around 1. So let's do like 0 to 2, right? Because I know 1 is in between that, right? The minimum y value is 0, maximum value y value is 2. So I'll be able to see the y equals 1. So now if I go to trace here, hopefully this traces out something nice. Oh, there we go. Ooh, look at that. There's our line. You see that?
Yeah.
Pretty cool. All right. Do you know how to calculate the intersection? Like where this happens?
Second calc.
Good. Second
right.
calc. You're going to go to intersect. Good. And then they say first curve. So you have to kind of like choose what the first curve is. So if you hit the up and down arrow, that'll switch between this graph and this graph. But it doesn't matter which one. I'll call it this one. Second one's this one. And then guess. Guess is important because you need to tell the calculator which intersection you're looking for. In this case, I'm going to move my cursor over so that it's right here. I'm going to hit enter. And there we go. That's one of the answers, 0.772. So that one's correct. Your teacher said this was wrong?
No, it was my own plugin.
Oh, okay. All right, that's okay. Right. And then you do the next one. You use second calc. Intersect. Scroll all the way over. No. Okay. There.
But what are the real answers? Is 0.772 or
0.77? No, that's right. 0.772. These answers are correct. But what was wrong? What was wrong, Bob? You just put those down like those are the correct answers, but you want to know how you got them?
Yeah.
Yeah. Okay.
Because I took the calculator and then I just without the y equals 1 intersect, I just did the arrow keys and then it was close enough. So.
Oh, I see. You just tried to move it close enough. You're just like it's there.
Yeah.
And that's one way to do it. But it's better to do that.
I think this is a good question also to do the practice for. Am I on the wrong page? Wait.
No, you're okay. You're okay. I was posting the second part of the question. Let me.
Okay.
And then to do a practice for what?
Because I was like, this is for the prime factorization thing.
Oh, ooh.
Good exercise for that because the numbers are not disgusting like 4,000.
Oh my god, yeah, that is a good point. Yeah, 1 sec. Let me let that load. Yeah. Oh, you're talking about the factors of this. Like, does this factor to something?
Yeah. So should I write it on
Yeah,
the
yeah,
board,
yeah,
or?
yeah. Right for it. Go for it. Go for it. This is
Yeah,
actually a good
you can,
little
like,
second teaching point.
Yeah. So I mean, if this needs to be the absolute value of this needs to be 1, essentially what you can do is like just ignore the fact that you don't need to put an absolute value. But if there is a solution that equals to -1, that also counts as well.
Right.
So that's how you want to do it. So you can do one case where you have t minus 13 t4 plus 12 over that thing equals to 1, and then another case where it's equals to -1.
Right. Which means you can just pull this all the way over to the other side.
Yeah, exactly. So you can equate this to 10 t3 plus 3. So this is one case.
Good.
And then the other one is t6 minus 13 t4 plus 12 equals to minus 10
t to the third minus 3. Do you see what? Do you see why that is, Bob? Because this whole thing it would be -1.
Yeah.
Okay. Good.
Yeah. So let's just like do one of these because they're already gonna kind of be long, but it's not gonna be super.
Not
bad.
super disgusting.
So you can simplify this to one side, writing minus 13t to the 4 minus 10t to 3, and then this will be plus 9.
Plus 9, yep.
To 0. Okay, so one thing you can do is you take...
Ooh, we can group this, can we not? No, not quite, no. I was seeing that we had the same difference in power, right? 6 to 3 and 4 to 1.
Yeah,
no, 4 to 0. No, it's 4 to 0, sorry. Yeah, no, it doesn't work.
Yeah, so unfortunate. So the coefficient of this is 1. So you take this and you multiply by 9. Okay. And then you have 9, right? Okay. So now you would write down all of the factorization of 9. So there's 1, there is 3, there is 9. So this is the only way that the 9 can be factorized.
Uh-huh.
Right? And then you will do plus minus for each of these. Because either... Now, these are 6 choices that you could have that are your solutions to this. Now, because these numbers are not, super bad, you can always just pretty much just plug it in and see.
I would just plug the 1 in. Just plug 1 in and just see what happens, right? We get 1 minus 13. No, it doesn't work. 1 doesn't work, right?
Yeah, 1 doesn't work. I don't think -1 works either.
No.
Or does -1?
Wait, so that's -1 is minus 14 plus 10. No.
Yeah, it doesn't work. And then we can do 3.
Yeah, do you want to do 3 to the 6th though? I don't want to do 3 to the 6th. It's like, ew.
Yeah,
I'll get it for you regardless.
Yeah, I think you can. One of these should be.
Okay.
3.
Here, what? It's x to the 6, right? And then it's minus 13x to the 4. This is another calculator trick that'll help you out here. Minus 10x to the 3rd plus 9, right?
Yeah.
Okay. And then what I'm going to do is I'm going to set x to different things. So I'm going to say that -3 implies x, basically. And that will do it for me. If I go up and I run this. No, that doesn't work.
No.
Try 3.
Okay. What about 3?
Yeah, I'm going to try 3. 3 does not. Okay. Is it 9, dude? What's up?
I don't think this is going to work.
It might not factor, honestly. It might not factor.
I thought...
Nope.
I thought prime factorization should work for this.
Does it work for everything? I don't think it works for everything. Not everything is factorable.
It works for everything that has integer values. But maybe it doesn't work. We can ignore it for now.
It's a good technique.
Yeah, it's supposed to work.
Maybe we did something wrong on one of the numbers.
Yeah.
Here, you check on the numbers. I'm going to help Bob with the second part of this real quick.
Yeah, that's good.
Long. You're good. All right, Bob, and what was this? Find the position of the particle at t equals 4. Is the particle moving away from the origin? Okay. Right? So this is correct. You just got to do the Jesus, this sucks. So wait, are you supposed to use a calculator on this?
Yeah.
That would make sense. Okay, cool. What else did they say here? Did they say the original position was something? Oh, at t equals 0, the initial position is 7. Okay, cool. All right. So this actually tells you something cool here, right? So the integral of velocity with respect to time, that always gives you the change in position. Okay? That's an important thing to know. So if I integrate the velocity here from 0 to 4, that's going to tell me how much the velocity changes. But then I need to add 7 to this, right? Because it originally was at the position 7 when this started.
Yeah.
Is this correct? Is this correct what you got here? Actually check it.
I think so.
Yeah. The other way to, yeah, you can check this by, if you go to, here, let's go to our function here. Let me just delete the absolute values. I'll show you another cool thing you can kind of do with the calculator here. You can tell the calculator to do this integral, actually, which is pretty cool.
Yeah.
So if I go, all right, so window, so now we want to go from x equals 0 to 4, so I'm going to say -1 to, I don't know, 5. And then the distance it scales, I don't know, let's do -5 to 5, just see what happens, you know? Okay, cool. All right, so if we trace that, that's what we get for the position.
What's the difference between the trace and graph plane?
Oh, it's a good question. Trace, I think, immediately puts it so that the cursor moves along one of the graphs, like it traces it. And for instance, you can do graph as well. If you do you see how if I do graph now the cursor doesn't ever follow any of the functions, right?
Yeah.
Okay. So then what you can do is you can say second calc. You can tell it to do the integral. You can tell it to do the integral right here. You can I can say integrate, and then lower limit is 0, upper limit is 4, and then watch this. It'll integrate it for you. Super cool. There you go. -2.88. Yep, that's good. And then you're gonna add 7 to that, and then that's your final answer for that one. Cool.
So then it's moving.
Okay. Is it moving towards the origin or away from the origin at t equals 4? Okay. So what I would say is that okay.
Because originally it was 7, and now it's less than 7, right?
Well, it's slightly less than 7, but here's also the interesting thing. At t equals 4, right? You see how it's gaining area?
Yeah.
So that means technically it's so for instance, if I go from 0 to 5, like let's calculate the integral from 0 to 5. Let's say 0 to even 4.5. Watch what happens. It's gonna grab it like a little bit more. See how do you see now how delta x is positive? It's 0.8. Okay. So, what's happening is that it's actually moving further away from the origin, right?
Okay.
Because delta x, the distance is increasing. You could also see this in the velocity. If you look at the velocity here at t is equal to 4, that's a positive number. And if it's a positive number, that means it's moving away from the origin, right? Velocity being, if velocity is positive and you're to the right of the origin, you're moving away from the origin, right? If I'm here and my velocity is positive, okay. But if I was negative and my velocity was positive, then I would be moving towards the origin instead of away.
Yeah.
Okay, and then they say, during the initial time, does the particle return to its initial position? Oh, it does. When do you think it returns to its initial position? This is actually kind of cool.
At 4.
So it does when the change in position is equal to 0, right? So when delta x is equal to 0, it is at its original position. Okay?
How do you know if delta x ever goes back to 0?
Good. All right. So when we did our graph, right? Which looked like this or something, right? Okay. So as we integrated velocity, right? This was delta x being positive. Okay, that means I'm getting further and further away from my original position. Okay. And then I started to add negative area, right? As I kept integrating, right? This was delta x is negative. Okay. And at some point, right? Specifically at t equals 4, right? I was already negative, right? So I went from being positively away from my initial position to negatively away from my initial position. So somewhere here, right, I had to be where delta x was equal to 0. Or basically like when the integral of the positive area canceled out the integral of the negative area.
Okay.
Is it there? And there's also another point where delta x was equal to 0, right? Where was that?
Like at 1.
So it would have been like slightly here. Do you remember here how the integral up to 4, right, was like negative 0.288?
Oh yeah.
But if I integrated up to t equals 4.5, I got like, what was it? I got like 0.88 or something. Yeah. So again, the delta x went from being negative here to being positive here. So I must have crossed my initial position again.
Okay.
Does that make sense?
Yeah.
Cool. Nice.
Yeah, thank you.
You're welcome, dude. That's a good calculator question. Ranton, you have anything to add with the the factoring mess this thing was?
No, I think this is just a really bad. Yeah,
it's just ugly.
On the theorem as well. So let me check just to. I'm pretty sure it works for everything.
Okay.
So let me.
Nice. One of the new students in the Discord said, "Damn, this feels like I'm watching a documentary of space. Mad interesting." Yes. Try to make science fun. Math and science is fun. And actually, I wrote this in one of my proposals to some angel investors or something. They asked me, "What do you do?" And I was like, "We make math and science actually interesting, not just for nerds, you know." And that's the unique part of this. Yeah, glad you enjoy it. Because there's plenty of resources for math and science for nerds. There's Khan Academy, there's YouTube. You can go on forever. But and I'm a nerd. There's nothing wrong with being a nerd. But we tend to get people who would not identify as someone who likes math or science, and then they start seeing, oh, math and science is actually pretty cool.
Yeah. So I posted it on the.
Okay.
How do I make this bigger?
If you hit S, you can click on it, and then if you hit Shift, you should be able to like expand it out. You see how you can move it around?
There we go. So this is called the rational root theorem, and it says if there is a polynomial with integers. Oh, there we go. Yeah, and then with integer coefficient. So integer is the key point, which we do have in here. But for some reason, it doesn't work. Even when I put it into Wolfram Alpha, I'm like, what is happening? Like,
okay, wait. It says A of n is not 0, and A of 0 is not 0. What? So the first coefficient and last coefficient can't be 0?
Yeah.
But
so
wait,
you need to
if the first coefficient, if the first coefficient is 0, doesn't it just like go away, and now this is the first coefficient?
Yeah, pretty much you can just factor an x. So
right.
Yeah, and then it becomes exactly. So I think they just mean like this is the most simplified version that you can have. And then so if you have a n, so p is the factors of this, and a q is the factors of this. So in here, where we have, what was our equation? So this came to the other side.
Yeah, Stancy was saying, like, isn't that a plus 10t cubed? Yeah, we have a minus and a plus, though, right? Because in one case, Stancy, in one case we made this -1, and then that's going to make all these. There's two solutions that you can solve for.
Yeah. So then we have a(n) equals to 1, and a0 is equals to 3. So actually we don't multiply. We should have divided. So, but regardless, it doesn't matter. It
doesn't matter. Anyway. Multiply, divide, whatever. Yeah, it's 1.
Yeah, all of the factors of 9 are 9, 3, and 1.
And all the factors of 1 are 1 and
1.
Yeah.
Yeah. So then x would be just the ratios of this. So 9/1, 3/1, 1/1, and then the plus minus versions of these.
Yep.
We should have a solution that is either 9, 3, or 1. And I put this into Wolfram Alpha. And
unless it never crosses the y-axis. right? Like,
Unless
could there,
it never
right?
crosses.
Well,
Oh,
if
that's
you have a polynomial that's doing this shit, right? You're never gonna factor something out.
that's true. Yeah.
Yeah. Where's that taken into account here? What happens if
Yeah, for some reason, this is supposed to work for everything, but
Yeah.
yeah, that's true. It's
math
like,
is a lie?
yeah, like I think this is kind of a handle. I think this is says it's a potential for this. To
I think
work.
so too. I think it's a potential. Yeah, I think you have to
It's
check.
not always.
Exactly.
Yeah.
Yeah. Yeah, Stanksy, just like the speed of light, dude, we're just destroying childhoods today,
Yeah.
dude. We're
just
destroying the
potential
childhood
rational
notion. It has potential.
Potential rational roots so yeah, it's not always true actually. I thought
Yeah.
it's always true if it has integer
Yeah.
coefficients, but no, if it has integer coefficients, works some of the time.
Some of the time. What's
Yeah.
what's that quote? Do you guys? It's from Anchorman. Remember, he's like 80% of the time it works 100% of the time.
Yeah.
He's like, Bob, this smells like gasoline. Singes the nostrils. I love that film. That's a good one. All right, let's do the last question with Ethan. The more you know, the more you don't know. Yes, correct, Strancy. Yeah, you're so right. Wait, Straznix. Sorry, I have to like go over to my monitor and read your full name. Straznix. That's a cool name. Straznix. Where does your username come from? Where does Straznix come from? Curious. Ooh, we're gonna do overlapping server. Might be tricky. I'm thinking we can use calculus for this, right?
I was gonna say that, but I feel like I want to do it without calculus.
I want to do it
with
without calculus. Calculus is
Yeah.
like taking the machine gun, just like we're like, I will get the answer eventually. You're like,
But I guess I think we can do it without calculus.
I think we can do it with a butter knife. Yeah, I think this is doable with a butter knife. We don't need to take the machine gun out on this one. What's up, Ethan?
How are you doing?
Good, man. I'm feeling actually. You know, my back pain actually is going away today. What the fuck? I still can't feel my fingers, but yeah. My dad being a doctor is helpful because he prescribed me a bunch of prednisone steroids, and apparently that's like fixing my back problems. Hooray for drugs! Medical drugs. Gold's on steroids. I am technically. I'm on a low dosage of steroids. It's for inflammation. Yeah. What's up, Ethan? This is a cool question. I like this one. This has to do with kind of some geometry stuff.
Is it easier than the others?
Yeah,
Okay.
for sure. I mean, even the other one was technically. I think the other one was made to be long. It wasn't obvious, but a lot
Yeah.
of the time, like it just because it's not clear, it doesn't mean it's like difficult.
Right.
Like,
Exactly.
It's you kind of just gotta find the right way. But the last one was not obvious and kind of tricky, so kind of was the
Yeah. And the problem is like even if we like taught it to you, like it wasn't gonna make much sense because it's a bunch of just algebra. So much messy algebra. Okay. Cool. Here, let's see. Yeah. What's up?
I'm actually improving on my science grade now.
Dude, that's awesome, dude.
You wanna know what I'm learning?
What are you learning? What are you learning in class, dude?
I'm learning for science and like the periodic table thing, right?
The what thing?
The
periodic.
periodic table.
Oh, the periodic table. Yeah, dude. I love the periodic table. That thing's dope.
That's dope.
And we're using formulas to like add up stuff. Okay.
Okay.
It's something called moles.
Moles.
Um,
Yes. Oh God. Yeah. Most kids when they see moles, they're just like, "What the fuck are moles? Like, what's this molar thing I have to deal with?"
Don't worry, it's simple. It's like you're doing math. Okay, it's easy for me. We're just doing the first 20.
That's good. I'm
elements.
glad it's easy to you, dude. It's I when I have to teach people about moles, I originally I'm just think of it like a dozen. Like how many eggs are in a dozen eggs? You know,
Are
how
you
many
doing this
atoms?
one?
Pardon?
I'm trying to see whether he's like. Is it this one that you guys are doing? Like something like that, or
Oh! I see. 1 second. Let me move the screen
Or-
over so I can see it.
is it not yet?
Oh yeah, no. I don't think I don't think he's doing orbitals yet.
Oh, okay.
What's
Yeah.
orbitals?
Yeah, exactly.
Don't worry about it.
Yeah, don't worry about it. I think we'll get there. We'll get there. I think he's calculating probably like atomic mass, like grams per mole or something.
Yes, exactly.
Grams
Because
per
see,
mole.
I can show an example. I can show an example.
Yeah, that's cool. You know, that would also be cool. I mean, yeah, also if like anything is hard for you in your chemistry class or whatnot, like we do chemistry as well. I teach a lot of
And
chemistry
biology and physics.
and physics. I have a degree in physics. Rampton has a degree in physics. We do a lot of the sciences. I just biology to me is like I don't like bio. Bunch of memorizing. Yeah. Let's see. Okay. Let's see if we can try to do this one without calculus. Yeah, because one way to do this is right to write these as like the equations of like some curves, and then to do the integral from this here to here, right?
Yeah.
We could
I
do
actually,
that.
I think I saw what it is, unless.
That's okay. Yeah, how do you do it?
I
I'm
know how
curious.
to. So like, this is a rectangle, and these are circles, right?
Yes.
So the radius of the circle is 5,
Uh-huh.
which means that this distance is 5,
Okay.
which means that this distance is 5,
Yes.
right? So now we can find kind of this length right here.
Wait, can I
Because,
rephrase the question?
How can we?
because we can think of it as like x,
Uh-huh.
right? So the distance between like right between these two. So we
Yes.
know that 5 minus x, so this part, plus x, that part, plus 5 minus x, this has to be 8. Because that's the length of this side.
Oh, okay. I agree with that. Yeah.
And then, so this, if we add this up, we will get 10 minus x equals to 8.
Uh-huh.
So then x is 2.
Ooh, okay. Yeah, that's sexy. I like that. That's cool.
So now you can draw a line here across this.
Uh-huh. Oh, this
And
is
then
cool.
this distance is half of it because of the symmetry. So it's 1.
Yes.
This distance is also 1.
Uh-huh. Are you going to draw
So
some
then-
triangles here?
No, this is a kind of a theorem that maybe not a lot of people talk about. So this distance is 4, right?
Yes, because x is, yep.
And then that's called this intersection, that the width that we are calling W,
Uh-huh.
right? So if that one's W, then half of it, which is where these two lines intersect one another, is W over 2, right? So this distance is W over 2.
Gotcha.
Yeah. So exactly. So
Trying to like draw some things
Yeah,
just so we can see a little bit bigger.
exactly. And then we can make it a half circle as well.
Yeah, we're only. Yeah, can I erase that actually? I think.
Actually, no. Keep the full circle. Actually.
Oh, keep the first circle. Okay. All right.
Yeah. So yeah, there's a thing called an intersecting chord theorem.
Yes. Yeah. Because this is a chord. Ethan, do you know what a chord is?
No, not really. Not
Okay. A
really.
chord is any line that crosses a circle.
That crosses a circle. Could you show me an example?
Well, this is
Like,
an example of a
There you
chord.
go.
That's
a
also a
chord.
chord. That's a chord as well.
There you go. This is a
Hold
chord.
on. Hold on. A chord is when a line is going through a circle.
From one point on the circle to another point on the circle. That's called a chord.
Okay, so these purple and blue line
Are technically chords.
made
Yes.
the chord.
Yeah. They do.
Okay.
Yeah.
Yeah. So the green one is like, let's say, a chord, but the purple one is not completely a chord,
Mm-hmm.
because it's not from one side of the circle to the other side, because it's to the half circle, right?
Yes.
So what we are seeing right now in this problem is like this is too high. So let's say this is halfway through the circle.
Mhm.
So what you want to figure out is that distance, the width, right? Which is like this distance.
Yep.
Right? Okay. So we know that this distance is 1.
Mm-hmm.
we know that this distance is also 4. And then because the radius is 5, this is also 5. Right? So you can use the intersecting chord theorem where it says if you have, what's it called? If you have two chords that are intersecting one another,
Mm-hmm.
I just want to make sure that I'm getting the formula right. Setting chord theorem.
Grasnick says punny. Or it says this strikes a chord with me. I'm like, yeah, that is punny. This strikes a chord with me.
Yeah, there we go. This is like a similar one. I'll just copy it off.
Yeah, just copy paste the image. That's what I do. Anytime I'm like looking for something, I'm just like, where is it at? Oh wait. Oh. So here's what you have to do. This is a tricky thing. If you've already copy pasted something on this board, you have to right click and say clear clipboard before it'll let you paste things back in from outside. Okay. It's annoying. It's because it keeps two different clipboards.
Okay. I will.
There you go. Got it.
Yeah. Okay, there we go.
Good.
So when you have this, you see, like, ignore the other ones. You see that intersecting chord theorem, and here it says that dB times BE is equal to BC times AB.
Oh, that's so cool. Yes, I remember this. Yeah.
So that's exactly what we have in here.
Right.
So your chords, the one chord is this one that is going. Oops. Chord is the one that is going across here, and the other one that is going across here. So where they intersect one another is like this point, right there. So because of this is symmetrical, this distance is W over 2. This distance is W over 2. We know that this one is going to be 4 plus 5. So, no. This will.
Yeah, that's the dB. The dB is 9, right?
Yeah, correct. That's 9, and this is 1. So, 4 times.
So 9 times 1. 9 times 1, right? dB times DE.
Yeah, sorry.
dB times BE. So we do this part times this part.
9 times 1 is equals to W over 2 times
W over 2. So yeah, W squared over 4. Okay.
Yeah. So then it would be W squared over 4. This is equals to 9.
W equals
so
6.
W squared is 36. Therefore, W is 6.
Nice. Okay, what are we gonna do with that W now, though? Is there a way to because this isn't a circle anymore, right? This is kind of more like an ellipse.
W is just that distance, which is exactly what so.
Oh, that's all they wanted was the width. Oh, I thought they wanted the area because I saw it was shaded.
No. Yeah.
Oh my god.
I go for that too. I was like.
Oh, that's clever, dude. That's super clever, dude. This is that's too funny. Nice, Rampton. Right. I was about to be like, yo, wait, how are we gonna find the area of this thing, dude? It's not a circle. Oh, that's too funny. See, it's why it pays to read the directions. Read the directions. I didn't even read the directions.
Yeah.
Fuck. That's pretty cool. Awesome question there, Ethan. I like that one. And yeah, we didn't have to do any calculus. Actually, we may not even had to have done calculus, right? Couldn't I just get 2 equations and then just find the intersection points?
Yeah, pretty much.
Yeah, that's the other way you could have done it. That's cool, though.
So I asked an easier question, so yeah.
It's okay. Yeah, no, I like that. No, it was still good. I learned from it. You know, I forgot about the whole intersecting chords theorem. I thought it was pretty cool.
Yeah, I've seen a bunch of it, like, in questions I had to like teach some people, and I was like, oh yeah, I forgot about this. Like without it, it's impossible to figure out some of these questions.
Yeah,
like, you can always prove it, but like if you don't have it at the top of your head, then you're not.
This is what I dislike about geometry is there's always because people have asked me these like chord questions before, and I'm just like fuck, like I don't remember those specific geometry relations for chords and circles and I know most of them for triangles, but the circle ones. Yes, Bob, I am so bad with that. Yeah, I always forget. Bob, it's because I get so excited doing your questions that I forget to give you a coin. No, you're good. Thank you.
Also,
Bob,
if you wanted to find the area of this, here's how you can also do it. So you can, let me do it like this. So you can construct a triangle like this. So you have the height of the triangle and the base of the triangle.
Yes, that's what I was gonna do.
And you can find this angle too. So you would just do the area of like this pizza slice minus the area of that triangle.
Yes.
And then they would give you that. And then you would just times 2.
Yeah. Yeah, okay, that's not bad. Okay, that's cool. Multiple ways to skin a cat. Weird saying, but yeah, that's what we use. All right, awesome. Okay. Thank you, everyone, for coming to Office Hours. Had a lot of fun learning with you guys. Appreciate the raid from English Lessons. English Lessons, let me know when you're streaming, dude. I'm happy to send people your way, too, if you want. Sorry, what?
I'm hearing music. I'm literally hearing music.
He hears music. Does anybody else hear music? I don't hear any music.
I don't know if it's just me. I don't actually hear music.
Oh, okay. Well, anyways. Yeah, thanks for all the new people that joined. Strasnix, good to see you guys. I'm glad. Hopefully, you found something cool here that you like. If you want to learn more, please join our Discord. We have that here. Here's excellent. There you go. That's our Discord. Join our Discord, and you'll find about all the cool things we do. We stream this 3 times a week. So there's our streaming schedule for here on Twitch. We're pretty religious about it. So Monday, Wednesday, Friday, and then it increases an hour every day between the days. So to give some flexibility between the West Coast and the East Coast people. And then we're doing a bonus stream tomorrow with me and Ramton. We're gonna do the Golden Hour AMA podcast. So this is a beautiful time for you to just come by and ask whatever question you have. It doesn't have to be math. It doesn't have to be science. It can be, though. We can go over... Ramton has a whole rabbit hole of cosmology stuff we can go through, if you guys are interested. I think that was really cool. A lot of people were really interested with that, And I learned some stuff, too.
We could depending on how much time we have as well, I was thinking that sometime I could do, a small segment on, special relativity.
Yeah.
Because, in, half an hour or an hour, you can explain, time dilation. Because and the only math that you need to know is pretty much just Pythagoras theorem.
Yeah.
And if you know Pythagoras theorem and
what was it, the space-time diagrams, PV diagrams? Yeah. What are they called?
Yeah, exactly. Yeah. It's the triangle one that you do with the laser in space.
And then there's the cone, right? There's the cone of the cone of relativity or something.
Oh yeah, that one becomes a past, I guess, a little bit
space-time cone.
Yeah.
I want an ice cream cone right now. Yeah, space-time cone.
But yeah, I think the good thing is you can teach the time dilation and length contraction in 30 minutes.
Yeah.
Using just high school, not even high school, because if you know velocity equals the distance over time, which is even if you don't
basic
know the
physics thing.
Yeah, you can just say, oh, this is what it means. So even that, it seems kind of it's something that we deal with on everyday basis. And then Pythagoras theorem, which I don't even know when I learned it, to be honest, but
I think algebra. Yeah.
And then that's you can learn something really cool. And I feel like that should be taught in high school. I don't know how many high schools cover special relativity time dilation.
I don't think many do, honestly.
Yeah, but it's such a cool idea, and it's takes such little math to learn it.
Yeah.
And you don't have to spend the time to go to university and take a course, and
And it's
just,
cool.
like, learn both
It's super. It's what I call like sexy science, because like people are just like, ooh, they're like, wow, like it starts to blow people's minds. It's really cool.
Yeah, exactly. Yeah, when I learned it, I was like grade like 10, I think.
Mm-hmm.
And I remember one of my friends told me about it. I was like, oh yeah, this is like so
Oh,
cool. Why is
man.
no one teaching this to
Yeah.
us? And then he was like, I don't know. So like I feel like there's a lot of cool stuff in science that,
Yeah,
like,
that's a good way that we could get people more interested in science. Yeah, maybe we'll do that as like a dedicated. We have so many topics. I love this though. I love having like a queue of topics that we can go through, because like the world is our oyster. It's infinite.
yeah, we don't have to like get into the like super involved math. Like we can kind of conceptually explain some of these stuff.
Yeah,
And
maybe
then
let's do like a first half hour or something about like special relativity. I'll tell the kids that.
Yeah, we could do that. Yeah.
Yeah. And then we could do the millennial prize stuff like another time or another week, and then
Yeah.
it's all about balancing, like, here's some cool stuff, and then like, what do you guys have to ask? And then like it kind of feeds on itself, honestly.
Yeah, that's true. Yeah, I'll like make sure I'm able to like explain that properly, because I mean,
Cool.
honestly, it's just about the coherent way of explaining it.
Yeah. You have to remember
but,
like the sign conventions on things, right? You got to be like, oh wait, is time going forward or backwards here and whatnot.
I think so. Yeah, I don't think we talk about forward or backward time with that one even. It's just basic, like,
Oh, just
math.
basic. Okay.
That's the thing I like about it so much. It's just like it's basically just Pythagoras theorem, and then you derive like one of the coolest results in like physics ever, and like it's
Dope.
just simple math.
Yeah, let's get people hyped, dude. I'm hyped for it. Let's do it.
Yeah.
Awesome. All right, cool. So yeah, guys, come by to our AMA tomorrow. It's gonna be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. If the other thing we do here with Action Education is we like to play video games and stuff. So if you want to come play some, I think Wednesday is Warzone. So if you want to come play some Warzone with us, we're gonna do that in the actual gaming channel. So stick around. You'll get rated over there. If not, it's good to meet you guys. I'm glad we got a lot of new people here. Come by tomorrow, join our Discord, and we'll see you throughout the week, throughout the year. All right, cool. I'll see everyone else. Head over to the Recess channel in Discord, and then I'll meet you guys over there.
Yeah, see you everyone tomorrow.
All right, peace.
Yeah.